Good morning, guys. This is Dr. Turner today for Integrated Math 2. We're going to be looking at 1.4, which is simplifying rational expressions. Simplifying rational expressions is a combination of two topics we've already covered in this class. One was 1.3 when we looked at what are rational expressions and being able to convert between rational and radical form, and remembering our rules of exponents. So what does that look like? Well, remember our 5 rules, and we'll just type them in here real quick. Your rules of exponents are your product rule, quotient rule, your negative exponent rule, your zero power rule, power of a power rule, your power of a product rule, and your power of a quotient rule. If you don't remember what those look like, you can go back and look at the previous video, but we are combining these rules with what we did previously in 1.3, which was being able to convert between rational and radical expressions. And again, there's a separate video for that, but if it's been a while or you're still a little confused, rational expressions or rational exponents are basically fractional exponents. So what that looks like is that if I have something, a variable that's involving both a root and a power, I want to be able to write it as a fractional exponent, and that makes doing operations a little easier, like we mentioned in 1.3. So remember, whatever the power is, that's going to go in the numerator of the fraction, and whatever the index or the root is, that's going to go in the denominator of your fraction. And vice versa, if I asked you to go the other way, if I had something like x equals, or x to the 4/3 power, and you want to put the power inside with the variable, and you want to put the denominator, the index, above your radical sign, okay? This section is about being able to perform operations with these expressions, and it's going to combine all the rules of exponents that we looked at. So let's look at an example here. Let's say I have something like x to the 2/3 power times x to the 1/2, okay? This is still going to be an example that is using our product rule, right? And so if you'll recall that your product rule is to keep the base and add the exponents. So that's what we're going to do here. Even though those are fractions, we're doing the same exact thing. Obviously, we need to remember how to add fractions. So this should be x to the 2/3 plus 1/2. And on the side, remember there's a couple ways you can do this in terms of adding fractions that have different denominators. So if you are adding two fractions that have a different denominator, you can do the TP method, you can do the butterfly method, or you're looking for the least common denominator. Between 3 and 2, that ends up being 6. And again, if that's your preferred method of adding fractions, that's fine. So we would multiply the left fraction top and bottom by 2. We would multiply the right fraction top and bottom by 3. That gives us 4/6 plus 3/6. Now that they have the same denominator, I keep the denominator, add the numerator. That gives me 7/6. So my answer here would be x to the 7/6 power. This is going to be true for any of the rules. So if I have something like x to the 3/4 times x to the 1/2, and let's say I take that whole expression and I'm raising it to the 2nd power. Again, my recommendation is that you simplify what's inside the parentheses, just like your order of operations. But if there's no addition or subtraction, you can get to the same answer regardless. Okay? So I'm going to take these two, and same thing. I'm adding 3/4 and 1/2, which again, you can do your scratch work here on the side. That ends up being 5/4, and I have that expression squared. So remember your power of a power rule says that you should keep the base and multiply the exponents. So that becomes x to the 10/4. Again, side note, right, if we're taking a fraction and we're multiplying by a whole number, remember you can put a 1 under it and then you multiply straight across. But we're not done, because just like any other problem involving a fraction, we have to simplify it if possible. Because these are both even, I know that I can divide top and bottom by 2. So my simplified answer is x to the 5/2. So what if I have something that's in a radical form instead of rational form? Let's say it's x to the fifth root of x cubed, and I want to multiply that by the cube root of x to the fifth power, okay? Now, while there are ways we could do this without using fractional exponents, that's the recommendation, and that's kind of the purpose of a 1.3, is being able to convert it. So I'm going to rewrite this. Again, your power goes on top in your numerator, your index goes in the denominator. Do the same thing here. I'm going to change this so your power goes in the numerator, your index goes in the denominator, okay? This is, once again, your product rule. So you're going to keep the base and add the exponents. So I'm trying to add 3/5 and 5/3. If you like the process where you need to if you like doing the process, oh, hang on 1 second. So if I was doing this, I personally prefer the butterfly or the TP method. If you're old like me, is what it was called. So you do 3 times 3 plus 5 times 5 over 5 times 3. 9 plus 25 gives you 34. So you have 34 over 15. Again, if that is a fraction that can be simplified, you should, but because 34 is a composite of primes, you're not able to simplify it. Okay? Let's do one more. Let's say I have x to the 2/3, y to the 1/2 over x to the 1/3, and I want to take that whole thing to the 6th power. As always, I recommend that you clean up what's inside the parentheses first. So I'm going to take that 2/3 and 1/3. Using my quotient rule, I'm supposed to keep the base and subtract the exponents. 2/3 minus 1/3, that gives me 1/3. And then I have 1/2. Now that the inside is cleaned up, I'm going to distribute that 6. And we are multiplying here. So 1/3 times 6 gives me 2. 1/2 of 6 gives me 3. So my final answer is x squared y cubed. There are more resources available if you'd like to look at the PowerPoint that's available or any of the supplemental resources. That's all for today, guys. If you have any questions, reach out to me, and have a good day.